are working on lesson 2.10. And this section is called percent change. We're going to start off with the formula for this section. Need to get to the right section. There we go. Let's start off with the formula. To do percent change, it is the absolute value of original minus the new, all divided by the original, and then times by 100. So let me show you how this works, okay? Super easy. You guys are going to like today. It's going to give you what the original is. So let's say the original is 75. Then it tells you what the new is. Let's say the new is 83. Okay? So we're going to start by putting an absolute value, original, which is 75, minus the new, which is 83, all inside an absolute value. Then we're going to divide by the original, which is 75. Then once we get that answer, we're going to times by 100. So 75 minus 83 is negative 8, but inside the absolute value, that's positive 8. So we have 8 divided by 75 equals 0.10666 times by 100, we get 10.67%. Now, here's the other thing we have to add today, okay? From the original to the new, does it go up or does it go down? From the original to the new, it goes up, which means this percent is an increase. We're going to draw a little arrow pointing up for increase. Okay? That's how this, huh? All right, so here we go with example number 1. And this is what you are doing for 7 through 15 to start. Find percent change. And let's say original is 1,200. The new is 1,350. So take the absolute value of the original, which is 1,200, minus the new, which is 1,350. All over the original times by 100. So 1,200 minus 1,350 is negative 150, but the absolute value of that is positive 150, divided by 1,200 is 0.125. Then we times by 100, and we get 12.5%. Does this increase or decrease? Increase. So we're going to take and draw an arrow pointing up. Or you can write the word increase if you prefer. Okay, let's try another one. Example number 2. Find percent change. Let's say the original is 12 and the new is 10. So we do the absolute value of the original minus the new divided by the original. Then we times by 100. 12 minus 10 is 2 over 12 equals 0.16667. Then I times that by 100, and I get 16.7 if I round percent. Does this increase or decrease? Decreases. All right, so give me your questions. Is anybody having any problems typing it in and finding them? Brayden? No, I'm just confused about the decrease. Okay, so all you have to do is look back at the problem. The original was 12. The new is 10. Does it go up or down? Oh, down. Okay. Right, that's all it is. Yeah, nope. It just goes back to the original problem. Is it getting bigger or is it getting smaller? Okay, let's try one more example from this section. Example number 3. Again, let's say the original is 12,600. The new is 11,250. Bigger numbers, right? So you have the absolute value of the original minus the new divided by what? Which is 12,600. And I'm going to times by 100. So first we start by doing the top. 12,600 minus 11,250. Yes, we get 1,350 divided by 12,600. And I got 0.1071 times by 100 equals 10.7%. Is this an increase or a decrease? Well, I heard a couple different things. Is it an increase or a decrease? There we go. It is a decrease, right? We're going from 12,000 down to 11,000, so it's getting smaller. Any questions so far? Should be super easy, right? Okay. Example number 4. Example number 4 is similar to 16 and 17. The population in 2020 was 5,652. In 2024, it is 6,905. Find the percent increase. Correct. Very good, Brayden. So we have the absolute value of 5,652 minus the new, or the current, which is 6,905, divided by the original of 5,652. Then we're going to times by 100. So I have 1,253 divided by 5,652. And I got 0.2217 timesing by 100. I get 22.2%. And I don't have to say it's an increase or anything because it already says it in the problem, right? Questions on this? All right, I have one more formula to give you. Okay? Next formula is called percent error. Percent error is the actual minus the estimate divided by the actual times 100. So it's really the same thing, just with a couple different words, right? Okay. Here is example number 5. Okay. Example number 5. This is going to cover your 18 and 19. Let's say I estimate that my friend is 53 inches tall. She is actually 55 inches tall. What is the percent error? All right, so we do the absolute value of the actual. What number up there is the actual amount? 55. Good, so 55 minus the estimate, which was 53, divided by the actual, which is 55, and then times 100. So 55 minus 53 is 2 over 55 equals 0.03636 times by 100, and I get 3.6%. Everybody agree? Okay. Any questions on that? Do we need another example? No, because it's a percent error. It's just how much you're off from what you should have been. Okay? All right, so go ahead and get started. You only have problems 7 through 19. Yes, it is all. Okay? If you want to check anything and see how you're doing, remember the odds are in the back of the book. So I need the work and I need to see how you put it in the formula. It's important that I see how you put it in the formula. Okay, is everybody hearing me? Okay, I'm going to say it one more time. It's important that I see how you put it in the formula. Okay? That way, if there's something that's off, I can figure out what's going on. Okay.